So good morning. If it's all right, I think we might go ahead and get started. Welcome to our conference, CEPE 2020-23. This is the virtual session of our conference, and we had our in-person conference last week and had a lot of really fantastic presenters. Hopefully some of our attendees from that conference in Chicago can join us here today. The theme of this conference would be human AI interaction in the future. And we're looking forward to a really fantastic, a really fantastic session this morning, and then also for the rest of the day. It's currently about 7 a.m. here in Chicago. I know it's a lot later in Europe, and thank you for your patience as we had to make a few very short adjustments to the schedule. You can find the latest version either in your email that I sent yesterday, or you can go to our website and you can find that there. We are hoping to record today, which I've already started. If you have any issues with being recorded, please let me know via chat, or you can go ahead and change your screen name to something anonymous if you would not like to show up during our session today. If you have we're hoping that each presenter will have about 20 minutes for their presentation, and then we'll do about 10 minutes of questions, and we can go over a little bit there. Because we have a nice compact audience today, we'll probably allow everyone to unmute themselves and ask questions of the presenter. But if you feel more comfortable having me read out your question, you're more than welcome to stick it in the chat, and I'll go ahead and read it out to our presenter. If we're ready to go, I think we'll get started. So our first presenter today is, sorry, I need to get to the right place in my schedule, I apologize. Franziska Poszler from Maximilian Gesslinger and Christoph Lung from the Technical University of Munich, Germany. And their presentation is a 5-step ethical decision-making model for self-driving vehicles, which ethical theories could guide the process and what values need further investigation. So Franziska, if you'd like to go ahead and take a hold of the screen, you should be a co-host now. You can go ahead and get started.
Okay, can you see my screen now?
Yes, it's very clear.
Okay, perfect. Yeah, welcome everybody. My name is Franziska Poszler, and I will give a presentation on ethical decision-making for self-driving vehicles, a proposed model and checklist of underlying values that need to be concretized in the future. It's a very long title, sorry for that. But it's based on a working paper that we are currently developing together with my co-authors, Maximilian Geislinger and Christoph Lüttke, at the Technical University of Munich in Germany. And before I start talking about a working paper, I would like to now it works. Talk about the relevance of this topic. So in general, what has been stated is that a lot of accidents happen because of human errors, such as microsleep or ignorance or things like this in traffic. And therefore, in general, it is assumed that self-driving vehicles are attributed to much higher levels of safety for all traffic participants involved. But as we can see also when looking at past accidents, is actually that also for self-driving vehicles, they may end up in situations with fatal consequences for traffic participants. So self-driving vehicles may need to make life or death decisions. But also apart from these accident situations, also in mundane traffic situations, self-driving vehicles will have to make decisions about how to distribute risks among traffic participants. So if we, for example, look here at the illustration from one of our papers, you can see that by selecting a different trajectory, the self-driving vehicle determines the risk level levels or the risks imposed to other traffic participants. So for example, if the self-driving vehicle selects trajectory A, a higher risk will be distributed towards the other motor vehicle, or if the self-driving vehicle would select trajectory C, the cyclist on the right or on the lower part of the illustration would receive higher levels of risks. And therefore, what the assumption is that in any case, self-driving vehicles will need to make ethical decisions in any case, so in accident situations, but also in mundane traffic situations. And therefore, similarly, actually, policymakers have highlighted the need to consider ethical dimensions within the programming of self-driving vehicles. So here are just a few examples of which regulatory drafts and ethical guidelines we considered and looked at. So the European Commission put forward similar documents, the UK government, the US government. There are ISO standards about this topic. And also, apart from the policymakers, actually industry is considering this a very important topic as well. For example, I was at one call last week with an automotive company, and they told us about how they're establishing an ethics by design team. So yeah, in research, in regulatory drafts, and also in practice, this topic is gaining a lot of attention and importance. But still, there are a few questions that are open. So what constitutes ethical decision-making for self-driving vehicles, and what actually should feed into the programming? And then how do we translate the existing ethical guidelines and the regulatory drafts into formal rules for use by self-driving, that are then used by the self-driving vehicles? And these are the two questions that we aim to tackle within our working paper. So we aim to lay out a potential approach for ethical programming of self-driving vehicles. And although our model is not exhaustive or kind of set in stone, we aim to approximate a decision-making process for self-driving vehicles during hazard situations, so during situations in which accidents are imminent, and this model or this process should align with ethical theories, shared principles, and policymakers' demands. And here is a very, very short glimpse or overview into the premises and requirements that were raised by policymakers and scholars in the past, and that represent kind of the fundament that we build on our model. So first of all, recent regulatory frameworks for AI in general, but also concerning self-driving vehicles, pointed to the importance of assessing and managing the systems by using risk-based approaches. And in the context of self-driving vehicles, this means, for one, that self-driving vehicles are expected to kind of calculate and minimize risks that they impose by calculating the collision probability and estimated harm, and then by selecting a particular trajectory that minimizes such risk values. And then the next premise is the adjustment of this risk management approach depending on the situation at hand, depending on the situation's criticality. So whether a situation is non-hazard or a hazard situation, and hazard situation means that at least one person suffers an injury that requires medical attention. And depending on the situation at hand, then different factors or consequences, such as, for example, risk levels, or meaning safety or the comfort of the traffic participants, are important when calculating and determining the best trajectory. Then thirdly, responsibility considerations and the protection of vulnerable road users. And here the idea is that you should allocate a greater share of risks to those road users who introduce risks in the first place, such as motor vehicles, while, for example, cyclists or pedestrians impose much less risks due to their smaller mass or velocity. And then lastly, implementing scholars and policymakers have highlighted the need to kind of create mixed algorithms that combine various ethical theories and that reflect norms and values of society. And based on these theoretical fundamentals, I want to now share our model that we're proposing. So this is the decision-making process that we've developed. The decision-making process consists of 5 steps. It starts with determining and calculating all possible trajectories that the self-driving vehicle has. Then the situation is typified. So are we in a hazard situation or are we in a non-hazard situation at the moment? Then in the 3rd steps, prohibited trajectories are excluded. Then in the 4th step, which we call calculation of valence adjusted consequences. So here we calculate the consequences by giving special weight to the safety of particular types of road users. And lastly, selecting the final trajectory. And what this all means and how these steps are kind of visualized or how we envision them, I will let you know now by going through all the steps in more detail. So step 1, the calculation of possible trajectories. So in the first step, the self-driving vehicle determines needs to determine all the potential trajectories and calculate the corresponding consequences. And we envision one scenario here, and in an imagined traffic scenario, the self-driving vehicle has 4 trajectory alternatives, which are 1, collide with an oncoming vehicle to the left, then trajectory 2, which is collide with a vehicle in front, and then 3, which is collide with a pedestrian on the sidewalk, and trajectory 4, which means crashing into a wall. And for each of these trajectories, the self-driving vehicle calculates then the consequences that would follow. For example, what risks would the traffic participants be or would endure. So and the risks are in literature usually calculated by using the product of collision probability and estimated harm. And other consequences that you could consider, for example, are the comfort of the passenger in the self-driving vehicle, for example. And I want to show you now a table where we kind of so here you can see a table which is the result of step 1. So this would be the outcome table for each trajectory. The numbers that we put down here are just examples to kind of better understand the whole process that we're proposing here. But step 1 would be, or the result of step 1 would be having this table where you have all the possible trajectories listed with all the outcomes for each traffic participant. Then in step 2, we have the typification of the situation. So here the self-driving vehicle determines the nature of the situation. So is it a hazard or non-hazard situation based on its ability to fulfill particular key duties. And exemplary duties are displayed in the table on the left. So, for example, the lives of traffic participants must not be put in harm's way would be one such duty that we could imagine. And this duty is fulfilled if, for example, or this would mean in practice that risk is not allowed to or must not exceed a figure such as 0.2. And please, I want to make it sure or make it clear again that these are just examples of duties, and also the value of 0.2 is just arbitrary here to show how our model would work in principle. But now we can take the outcome table that we calculated in a previous step to assess to what extent the self-driving vehicle can comply with these duties. And we see with any trajectory, the self-driving vehicle cannot fulfill these duties, and thus it declares, okay, we are in a hazard situation here, so an accident is most likely to occur, and therefore I, as the self-driving vehicle, have to switch in a hazard situation mode. And a hazard situation mode means that the only consequences that the self-driving vehicle is allowed to contemplate in its calculations is the risk values, so the safety of the traffic participants, while other consequences such as the passenger's comfort are to be neglected. So here we can cut out the comfort values. Now we move on to the step 3, so exclusion of prohibited trajectories. And to identify prohibited trajectories, the self-driving vehicles checks the consequences of all trajectory alternatives for each traffic participants against particular risk thresholds. Again, here on the left, you can see exemplary threshold restrictions in table 3. For example, if the collision probability exceeds a particular risk or particular thresholds, such as 80%, for example, for at least one traffic participant, the value for estimated harm must also not exceed a particular threshold. And then those trajectories that fail to fulfill particular threshold restrictions are then to be excluded. So in our example, this is, for example, trajectory 3. Therefore, we exclude that trajectory for the further steps. So, but all the remaining trajectories are then further considered in the next step, step 4. So 1, 2, and 4 are still considered. And in step 4, we calculate what we call valence-adjusted consequences. So as I said, now we have 3 potential trajectories left, trajectory 1, 2, and 4. And the self-driving vehicle then re-evaluates all remaining trajectory alternatives by adjusting risk values with valence factors for different traffic participants. For example, traffic participants could be classified into pedestrians, cyclists, and vehicles with kind of gradually declining valence factors as illustrated in table 4. And in our case, we have 2 different traffic participants, which I showed you in the first illustration. So we have motor vehicles and 1 pedestrian. And based on these valence factors, we then calculate the valence-adjusted risk values that feed into the decision-making process of step 5. So these valence-adjusted risk values then feed into the next step, into the final step. The final step is the selection of the final trajectory. And this is quite complex, and I actually don't show all the calculations here on the slide that feed into this step. But what I want you to understand here is the aim is to identify the one trajectory that meets 2 distribution principles: the greatest equal risk between traffic participants and the lowest aggregated risk. So for each trajectory, we calculate how equally then the risk distribution distributed between all the traffic participants, and what is the sum of the risks for when selecting a certain trajectory. And to what extent these 2 distribution principles are factored in is also predetermined with a weighting factor for each principle. Here you can see that we put down as exemplary weighting factor each 0.5 for each distribution principle. And then giving these weightings, the self-driving vehicle can then select the final action, so the trajectory that has the lowest, how we call it, weighted inequality aggregated risk value, which means the trajectory that distributes risks most equally between all traffic participants, as well as has the lowest aggregated risk in total. And in our case, in our example that we put down in our working paper, this would be trajectory 1. So all the other trajectories are excluded, and the self-driving vehicle would decide to swerve towards the left. To sum up, I want to provide a few benefits of the proposed model. So first of all, this model states a clear sequence of steps with which a self-driving vehicle could engage in and execute an ethical decision-making process, and all is rooted on previous insights in the scientific community and quotes from policymakers. And the model offers many possibilities for adjustments, actually, by, for example, not putting down the final values for duties, thresholds, or weights in concrete terms, but leaving them actually up for debate, which I will highlight again on my next slide. And also some other benefits is, if we think back about the premises and requirements that I stated in the beginning, this model, for one, adopts risks as a key pillar from the beginning. So it's a risk-based approach. It takes into account and adapts to the context at hand. So traffic situations are separated into hazard situations and non-hazard situations, which then is decisive for what parameters such as risks or safety or comfort are considered in its further calculation. Then it incorporates responsibility considerations and the protection of vulnerable road users, namely by providing pedestrians with a high valence factor, while vehicles have a low valence factor in our model. And lastly, throughout this model, a plurality of ethical principles or theories make up the body of the decision-making process. So just to name a few, we have deontological ethics in the form of duties, and we have utilitarian considerations and the equality principle in the form of distribution principles that are weighted against each other in step 5. And furthermore, this model kind of allows the alignment with societal shared principles, which I will elaborate now on my next slide in more detail. So here I want to kind of finish with a research agenda and values that need to be determined to kind of turn this model into practice. And as we can see, for each step, we need a few concrete values. So for example, executing step 1 requires the determination of estimated harm. Executing step 2 requires the fixation of duties. Executing step 3 requires that we need certain risk thresholds. And then the following steps also require that we need to establish between which types of road users we want to distinguish and what would their corresponding valence factors be. And the last step asks us or requires us to establish weighting factors for different distribution principles, which in our case is risk inequality or equality and aggregated and minimizing aggregated risks. And of course, we have to ask ourselves, how can we establish these? Because here in our working paper, what I want to emphasize again, we only included exemplary numbers as placeholders. But in the future, what we could do is that we can approximate the true value or the value that we should use for these duties, thresholds, and weights We could rely on indicated preferences or consensus within empirical studies. We can engage in deliberation among key stakeholders and ethics committees, but also we can look at other fields of what they are proposing there as kind of thresholds or distribution principles. For example, in healthcare, there's also the principles of treating people equally versus maximizing total benefits and things like this. So this slide can serve as like a kind of checklist for future research that could extend our model. But what I want to make one last very critical remark. We need to be cautious about what we are ultimately kind of programming into self-driving vehicles and into technology in general. And therefore, I want to say, while our model aims to establish an ethical decision-making process for self-driving vehicles that does align or that aims to align with previously identified requirements of policymakers and the scholarly community, we still need to further validate the legitimacy of this model in the future. And to do so, what is very important as a necessary step in the future is the empirical assessment of this self-driving decision-making process. And with this, I want to stop my presentation. Thank you very much for listening. And yeah, let me know if you have any questions.
Thank you so much. That was really wonderful. So we will open up the floor for questions. Since we have a nice number of people, if you'd like to go ahead and raise your hand, and I will call on you, and you can go ahead and unmute yourself and ask the question.
Also, if you have any critical remarks, let me know, because we currently have this under review somewhere. So I'm always happy to incorporate more feedback.
Mm-hmm. You can also go ahead and put your question in the chat if that is more amenable. Monica, go ahead.
Okay, hold on one sec. Hi, thank you so much for the presentation. I'm actually live in Phoenix, United States, and actually yesterday it was announced that Waymo, which is Google, partnered with Uber in the expansion of robotaxis. So living here, I've been witnessing how these vehicles drive, and so far I haven't seen anything that it's off or etc., to the point that there are other companies expanding here, which is called May Mobile, that it's based in Michigan. So for your model, is this something that, you know, these companies can still learn from the ethics point of view, or they are already at a stage where they have considered some of these points? So how do you see it? Do you see this application more for areas, you know, of countries where they still working on it, or do you think that it still has a lot of value for these companies and their, you know, degree of progress at this stage? Thank you.
Yeah, thank you for your question. And I believe it's valid or important for any country or any company. So I can give a little bit of, I can show one slide where this is in a backup. So I've been working on a project which is called Autonomous Driving Ethics with an automotive engineer starting in 2019. And what we did there is we kind of looked into what is the status quo of self-driving vehicles, how they decide, and what could we improve, or what would the implications be. And this is just a simulation that we ran. On the left-hand side, you can see what we called the selfish risk distribution, where the only risk value that was considered was the risk for the passenger within the vehicle, because we assumed that any automotive company would only like to build vehicles that are kind of saving their passengers, because it makes sense, and it's a valid point. And we saw some statements that go into this direction back in, I think it was from 2014 and 2016, some statements by, for example, Mercedes-Benz that said our vehicles are going to save the passengers inside the vehicles, and maybe even by sacrificing other traffic participants. And there was also a Google patent in 2016 or something, which had a similar idea of how to distribute risks and how self-driving vehicles would drive. And compared to this, we then showed, okay, if we have different ethical principles, and if we would include that in the trajectory planning of vehicles, we could see that the self-driving vehicles would drive differently and would kind of more fairly or more equally distribute risks. As you could see, they would, on a picture on the right, they would have a lateral, or they would move the lateral position of their vehicle much more away from the cyclist. And therefore, I think even without our work, I don't believe that these selfish risk distributions are not that existent anymore in practice, because we are talking to automotive companies, and they are making changes that they do consider, okay, we also need to consider all the traffic participants and not just the passengers without our vehicles. But I can imagine that also the regulatory drafts and regulations that are put out there will vary across countries. So I know that in Germany, at least, there are regulations that are very concrete on how we should prioritize vulnerable road users, while maybe, maybe in the US, I don't know if there are as many regulations in this regard. So I can imagine that there are country differences, but I think in the long run, or hope in the long run, that throughout the world, the self-driving vehicles are not allowed to just consider the safety of the passengers.
Okay, thank you.
We have time for probably one or two more questions.
I just ask very quickly, where do you come down on the whole law situation? Right. I mean, if you look at the moral machine at MIT, one of the questions they always ask is, well, if you have two victims that are equal, but one of them is breaking the law, should you hit that victim or not? How do you, or do you calculate law into your own process? And then just as a quickly, sort of a second part, like connecting with Arizona. So I live in New York City. And in New York City, you can't drive more than 2 blocks without breaking the law, because there's constant construction and barricades and everything. So there's if you have that sort of alert system on that you're talking about, right, where there's a certain percentage chance it appears there might be an accident. I mean, in New York City, every 2 blocks are going to be going into the into the emergency, right, the emergency mode. So I'm curious how you handle the idea of the law in general, and then specifically the law in cases where in big cities, Central European cities, I mean, in the center of European cities, where there's just kind of chaotic driving. What does that look like to you and for your program?
So thank you also for your question, which is very legitimate. And we actually talked also with the automotive company last week about that. So far, we consider, or we included a responsibility principle, but the only responsibility principle that we have is that, okay, those people that bring more, or those traffic participants that bring more risks into the traffic should also bear more risks. The distinction that we propose here is only depending on the kind of velocity or the speed, the mass of the traffic participants, and we distinguish between the three types of traffic participants here. What you could argue is also that, of course, traffic participants who break the law bring more risks into the traffic situation. But at the moment, we haven't considered this, to be honest, because we also didn't find anything in existing regulatory drafts that would justify this.
Right.
Yeah, but if you have any kind of also scientific papers or regulatory drafts or laws that go into this direction, please share them with me. Because I remember also that in the moral machine experiment, there was this one example where you could select that those people who go on or pass a red light, whether they should then be hit or not. So yeah, and regarding your second question, this is also what we pointed to in our kind of future research agenda, that we now need to test whether this theoretical model actually holds in simulations and holds in real traffic scenarios. And here you can start with simulations of very busy road traffic, and then in very easygoing, chill traffic situations. But so far, I don't have an answer to that yet.
Yeah, I think it's a long road that you're on, but seems like a good start. Thanks.
Thank you.